Hi guys, good day. It's me, Teacher MJ. Our topic for today class, it's all about Right Triangle Similarity Theorem, or we call this one RTST. So without further ado, let's do this topic. So we are told to find x, y, z, and m in this given illustration. Once again class, if you want to learn more about Right Triangle Similarity Theorem, I will just put the link in the description down below. Those are basic examples class of Right Triangle Similarity Theorem. You need to see the first video class before answering these complicated examples. So once again, we're told to find this one x, y, z, and m. So in this example, to find this leg AC, that would be the product of AD and AB, and you get their square root. Now to find CB, this leg, that would be the product of DB and AB, and you get their square root. Now to find CD, this altitude M, that would be AD and DB, AD times DB, and then you get the square root, that would be the altitude. So once again class, feel free to see the video, the first video, before answering this one, because this will be quite complicated. But do not be worried, we will be explaining this one step by step. So we cannot find x because we don't have AD. Okay, this is y, so therefore we cannot find x. So in this scenario, can we find z? Yep, we can find z because we have CB and we have AB. We don't have DB. This is z. So we can find z using this leg formula. So to find z, this will be CB. Okay, to find z, this will be CB is equal to the square root of, once again, if you're looking for this leg, that would be this leg, then the square root of this side, DB, this segment, the small segment near from CB, DB, then the hypotenuse. So that will be DB times the hypotenuse, that is AB. So that's how you find the leg class. Once again, feel free to see the first video class. We actually derived the formula on that first video. So CB, that is 6, substitute, square root of DB is z, so we don't have the value of DB, that is z, so write z, times AB, so AB is 18, times 18, so this will be 6 equals, so z times 18, that would be 18z. Alright, so this will be 6 equals, do we have square root of 18? Nope, we don't have the exact number for the square root of 18, but we can simplify 18. You find a number, two numbers, one number is a perfect square, the other is not, that when you multiply, you will get 18. So we can simplify this one by 9 times 2, then copy z. So this is 6 equals the square root of 9, that is 3. We put it outside the radical symbol. So copy 3. Do we have square root of 2? Nope, we don't have square root of 2. And we don't have square root of z. So simply copy 2z, square root of 2z. Now, so that we can get this z, we need to divide both sides by 3, so that the remaining equation will be only square root of 2z. Divide by 3, so cancel this out. 6 divided by 3, that is 2, is equals to square root of 2z. And to get z, do you still remember class, solving radical equations? So we can square both sides, so that we can cancel this square root. So cancel this out. So this will be 2 times 2, that is 4, equals, so we cancel the square root, copy 2z. And to get z, divide both sides by 2, cancel this out. So 4 divided by 2, that is 2, equals z. So our z is equals to 2. Alright, so z is equals to 2. Alright, so z is equals to 2. Now, can we get y? Yep, because AB is 18, therefore AD is 16. 18 minus 2, that is 16, right? Because AD plus DB, that is 18. And 16 plus 2, that is 18. So therefore, this AD is 16. 18 minus 2, that is 16. Because AB is 18. So y is equals to 16. So let me write the answer. We have z is equals to 2, y is equals to 16. Alright, so can we find this altitude? Yup, we can find this altitude because we have AD and DB. Alright, let's find M. Alright, let's find M. So once again class, feel free to see the video class. We have basic examples in Right Triangle Similarity Theorem. You need to see the first video class before answering these complicated examples. Alright, let's find m. So the altitude, that would be the square root of the product of AD, this segment, and this segment, AD times dB. So m, or CD, is equal to the square root of AD times dB. Alright, so this will be CD, or CD is m, so m. Okay, so we have m is equals to AD is 16, so we have y, that is 16, so AD is 16, times dB is 2. Now, in this scenario, class, before multiplying 16 times 2, you always check, class, if there is a perfect square. Why is that, sir? Because if there's a perfect square, we can put it outside the radical symbol. Is 16 a perfect square? Yup. So 16 is a perfect square. We put it outside because the square root of 16, that is 4. Copy 4. Then do we have square root of 2? Nope, we don't have square root of 2. Simply copy square root of 2. That's the answer, class, for m. 4 square root of 2. Now, if you're confused, let's have this another solution. So m is equals to square root of 16 times 2. So 16 times 2, that would be square root of 32, right? Now, do we have square root of 32? Nope, we don't have the exact number for the square root of 32. But we can simplify square root of 32. That would be square root of, you find a number, one number is a perfect square, the other is not. So that would be 16 times 2. So the square root of 16, that is 4. We put it outside. So that would be 4. Then simply copy square root of 2. We don't have square root of 2. Simply copy square root of 2. Same answer, class. But for me, class, you always check inside the square root if there's a perfect square. If there is, so put it outside, class. Get the square root. So m is equals to 4 square root of 2. This is 4 square root of 2. So m is equals to 4 square root of 2. Alright, last one for x. Let's find x. Easy, right? For right triangle similarity theorem. So if you understand this one, this will be very easy, class. Alright, let's find x. So to find this leg, so that would be CA is equal to, so this leg, that would be this segment times AB. So that would be the square root of AD times AB. So to find this leg, to find x, that would be AD times AB, and you get their square root. So that would be the square root of AD, this near segment, and then the hypotenuse times AB. So CA, or x, is equals to the square root of AD is 16 times AB is 18. Alright, so x is equals to, imagine, class, if you multiply 16 and 18, those are large numbers. 16 times 18, those are large numbers. So you always check, class, if there is a perfect square. Do we have a perfect square? Yep, 16 is a perfect square. We put it outside, the square root of 16, that is 4. And then copy square root of 18. Can we simplify square root of 18? Yep. What would be the square root of 18? So copy x is equals to 4. The square root of 18, that's correct. That would be 9 times 2. We can simplify square root of 18. That is 9 times 2. 9 is a perfect square, then 2 is not. So x equals, copy 4. The square root of 9, that is 3. We put it outside. Then we multiply it by 4. So 4 times 3. Then we don't have square root of 2. Remain. Copy square root of 2. So x equals 4 times 3. That is 12. Copy square root of 2. That's it, class. That's the answer for x. 12 square root of 2. Alright, so that's it for the right triangle similarity theorem. Once again, if you want more examples, I will just put the link on the description down below. We do have more examples, class, with regards to right triangle similarity theorem. Now, you try this one, class, and you put your answer in the comment section down below. Let me check, class, if you really understand our topic. So what if you are told to find this one? Okay, let me give you another example. And you try this one, you put your answer in the comment section down below. So what if this is 8 and this is 2, and you're told to find x, y, and z? You try that one, class, and you put your answer in the comment section down below. Find x, y, and z. Alright, so once again, I hope you learned something new today. If you like this video, do not forget to like, share, and subscribe. You share it to your friends and to your classmates so that we can help more students. Once again, this is Teacher MJ. You have a great day, class. Goodbye for now. Bye-bye.